Hey everyone, welcome back to my channel, and this is the next video wherein we are going to discuss a new problem related to the binary search tree. So this is going to be a start of new series wherein I'll be coming up with some videos related to the trees data structure, wherein I'll be explaining the coding part as well as the logic behind every kind of a problem statement, right? So this is the very first question. It's an easy level problem where I'm starting with, and just to show you this in this particular video, I'll be explaining the coding part and just to have a basic understanding what this problem means, right? So it's going to be a quick tutorial. I'll be just explaining you just from the surface. So for this video, I would be suggesting you to have a fair understanding about that binary search tree as well as some arrays and also the recursion, right? So I'm not going to be getting into the depth, just going to explain the coding part, right? So basically this problem statement is pretty simple. It says that if you have the basic understanding about the binary search tree, then you must have been aware of this particular point, that the in-order traversal of the binary search tree converts to the sorted array. So that means there is a little bit of link, and you can say relation that is there in between the binary search tree as well as the sorted array. So the inverse can also be done. Like if the sorted array has been given to you, then you can also convert that into binary search tree. So that's what we have to implement, right? So basically this is let's just imagine for a case as an example, this is the nums array which is given to us, which is a sorted array. So what we can do, so firstly, the very first thing which comes to the mind when a sorted array is given to us, then we can implement something called as binary search. This is something that we know. I mean, this is something, if you have worked on the quite many problems of sorted array, then this is the point which comes to mind, right? So that's what we have to do. We can implement some kind of a binary search, right, to a sorted array. So let's try to understand what can be done. So this is a sorted array. Let's try to find out the middle element. So these are basically 9 number of elements over here. So the middle element which comes to this array is going to be the number 7. So let's do something right related to that. So what I'll do for you, I'll put these first 4 elements over here, and this 7 element, this is going to be the middle element over here, which I'm going to be placing over at this position. And let's take the other 4 elements as well. So when I do this thing, you can see that all the elements which are greater than to this number 7 are on the right hand side, and all the elements which are less than to number 7 are on the left side. So it's kind of a, you can see that it's a property of a binary search tree as well, and that's what we have to do. So we can do this in an iterative manner, that whatever the element we find out from the middle element when we do the first binary search, we can put to the left hand side. So that means if I'll just create these numbers as the nodes, I can create a binary tree itself, right? All the numbers which are less than to this number 7, I just need to create the nodes and have to place that to the left hand side. And all the numbers which are greater than that of number 7, I can create the nodes and I can put that on the right hand side. If I'll do the binary search again on the left hand side, if I'll take the middle element once again as number 3, I can create one more level. I can take this as a node and put number 2 on the left hand side, right? That is something which I can do. And if I'll take the number 4 and 6, right, I can place that over here, and this number 6 again at this particular location. So that means I just have to do it on the iterative way and have to implement the tree. Whenever I find out a middle element, I just have to place that as a node, and whatever the numbers which are coming as a greater one to that one, I have to be placed on the right hand side, and the smaller to be on the left hand side, right? So this is the basic logic which we have to implement. So let me just explain you the code and have to implement the same. Maybe that's going to help you to have a better understanding for this particular problem. So as you can see on the lead code itself, let me also show you the pictures over here. Maybe that's going to help you a little bit better. You can see this is the binary tree which has been given to us, and you can see, okay, right? So this is basically the array which has been given to us. It's a sorted array over here and have to convert into the binary search tree, right? So you can see when I found out this particular number 0, let me show you this thing. Okay, so this is basically the middle element for this particular array, right? All the elements which are on the left hand side are basically the smaller ones. So what they have done, they took -3 as a number, they created a node of it and place it on the left hand side. This is something which we have to implement. And again, if we take the -10 as the next element, have to be placed on the left hand side, right? That's what we have to do till the time we have the elements left. And I will also explaining you this binary search as well once again, so that you can have a fair understanding. So when the array is given to us, we just have to find out its lowest index, okay, the very first thing, just to implement the binary search. And next thing which we have to do, we have to find out the highest index, right? This is the next thing which we have to do. So what I'll do over here, I will create a new method just to implement the binary search in a proper way, right? Okay. So, and also we have to return the node over here. So that means it has to have some kind of a return type. So what I'll do for you, whatever the method which I'm going to be creating new as a new one, I will be taking and I will be returning a node from there so that it can be simply returned to the main method, right? So I'll pass on the elements as low, I'll pass on the element as high, the highest index, and also something called as the array which we have to pass. Okay, so this is something which we have to implement. So this new method needs to have some kind of a return type. So just to, you know, mention over here, because we're going to be returning the node itself, so I'll just take it as a tree node, and the method is going to be binary, and it has to have some elements that will be passed. So it will be having int low, int high, and also something called as the int array, right? This is something which we have to create. So let's proceed further and try to implement the logic. First of all, whenever we do the recursive problems, we need to mention the base condition. So I'll mention the base condition over here, that whenever, just like as the way we do it in the binary search, right? That is something which we have to do. So if the lowest index is going to be greater than that of high, we just have to simply return the null. We don't want to do anything, right? We just want to exit out from this particular recursive method that we're going to be calling, right? Next thing, we need to create a node, because that's what we want to do, right? And also for the binary search, we also need to find out the middle element. So that's what we're going to be doing over here. So let's try to first of all find out this thing. So this is the key point which I want to mention over here, that I don't know if you are aware of this or not. Let me mention this thing, that don't do this thing. Like if you have to find out the middle element, don't do this thing like something like this, low plus high divided by 2. Just don't do this thing, because most of the people tend to do this kind of a thing, and that also lead to some kind of a error. The error is simply coming out because we take this to be as an integer, right? This particular thing. So it has some specific range, right? So integer has some kind of a specific range. Just imagine for a fact that you get the high and low as a very high number, because sometimes it happens for some particular problems, the constraints which are given to us, it actually has a very high value. So if that is being implemented, at some point you will be having that as a very high value. So that's going to lead to some kind of a compile time error. So in order to make sure that it's going to be having the same implementation, it's going to also going to result the same thing. But by doing this thing, you will do the minus first, and that's itself going to lead to a smaller value, and when that will be divided by 2, it's going to lead to a very small value, and that will be just itself going to be added to the low. So that itself going to lead to a very small value. So just whenever you have to find out the middle element, just don't do this thing, because that's going to lead to a very high value at some point, and then it will be divided by 2. So then, but before that, it's going to lead to the compilation error. So to be on the safer side, and also for the interview perspective, maybe interviewer is going to ask you that why you have done this thing, or maybe that itself it's going to be a point that if you do this thing, if you do this kind of a part, then interviewer will be able to understand that you have the fair understanding about the same, right? So yeah, talking about let's come back to the point wherein we have to create the node for the binary tree. So now I'm going to be creating the node over here, just a simple basic syntax just to create a node. So you can see that there is a constructor which has been made in this method over here wherein they have implemented this tree node class, right? So over here, when I will pass on the value to that node as a constructor, then itself it's gonna, just simply take the value for that particular node. So that's what I'm going to be doing over here, because whenever we find out the middle element, we have to pass on that value to the node which we're going to be creating, right? So as of now, we have just done the binary search. So we have find out the middle element. We have also mentioned the base condition, right? So this is basically the base condition which we have mentioned over here. Next thing which we have done over here, we have created the node. Every single iteration is going to be creating a new node, and the value will be passed on as a nums mid, because we want to pass on the middle element. Next thing which we have to do, we have to create a left node for that thing. So this time what I'm going to be doing, I will be calling the same method recursively, right? So root.left is going to be something which will be created by calling the same method once again. So this time when I'm creating the left node, so that means for this particular, I have to create this left node, which is the number -3, right? In order to create the left node, what I need to do to implement the binary search, that you need to have a lower element and lower index, and also the highest index, right? So this time my lower is going to be the same, but the highest index is going to be mid -1. The reason is simple, because we need to check the elements which are on the left hand side of the middle element. That's the reason the highest index is going to be mid -1. Last thing is going to be the same, right? We just have to pass on the array. Let's go to the next point, which is going to be the right node. So that's going to be something called as binary. Once again, we have to create the binary method, and this time my lower index is going to be something mid +1, because we have to check for the elements which are greater than that of the middle element, and the highest index is going to be the same one, right? Nums. At the end, we just have to return root. That's it. Pretty simple, right? We haven't done much thing. We just have implemented the binary search itself. Just mention the base condition over here, that whenever the index is going to be lower, greater than high, we just have to return the null. We created a node inside of the inside of the method. We created the left node, we created the right node based upon the binary search. Just like the way we implement the binary search, we simply return the root value. So that means every time the function will be called, it's going to be returning the root value, plus also going to be returning something called as the left as well as the right. It's going to be creating the left and right. So yeah, that's pretty much it. Let's try to execute this code. I hope it's going to work, because it's pretty simple, and it seems out to be like it has been accepted. Case 1, case 2 has been, the basic cases has been accepted. Submit this code. I know that it's going to work, right? It's pretty simple. We have done the logic bias very nicely. So yeah, you can see that the code has been accepted. Yeah, pretty simple, right? You can see that it beats 37.96. Yeah, pretty much simple, right? Pretty cool. So yeah, that's it in this video. I hope you liked the discussion as well as the logic implementation. I'll be coming up with more complex problems as well in the later part of the videos. So just gonna be starting a new series wherein I'll be just quickly gonna be having some 15-20 videos related to trees. I'll try to create those videos often. So yeah, that's it from my side in this particular video. I hope you liked it. Thanks for watching. See you next time.